Okay, so practice problem number 10 for module 15 got cut out of that last recording. So this is this recording will just be practice problem number 10, module 15. So I've gone ahead and drawn up the circuit here, and what we are asked to find in this circuit is the power. Okay, so we have the voltage given here as 120 volts, and then we have these various resistances. And so what we have to do with this problem is determine which of the resistors are in parallel and which are in series. Okay, so if we look at this and we think again about the fact that the current is going to start at the positive, and it's going to go through all the way around to the negative. Well, the first thing we see is that it must go through this 31. Okay, so that one would be in series. And then when it gets up here, now it has some choice to make. It can go that way or it can go that way. So these two are in parallel. Then it comes back together again. And then down here again, it has a choice. It can go each one of these two ways. So this is in parallel. And then it comes out of there and goes through here. So we have one that is in parallel, the other two are in series. So so we know that the 31 ohm, that one is in series. So we'll keep that off to the side and add that in at the end. Okay, then we have a 27 and a 21 that are in parallel. And then we have a 15 and an 11 that are also in parallel. Okay, so these are all ohms. Okay, so 1 over R effective will be equal to 1 divided by 27 plus 1 divided by 21 plus 1 divided by 15 plus 1 divided by 11. Okay, so this is 0.037 plus 0.048 plus the 1 over 15 is 0.067, and 1 over 11 is 0.091. Okay, so each of these are going to go 3 places beyond the decimal place. So this is going to be 0.085 plus that is 0.158. So then we can add those two together. So this would, if we take 1, so then to get R effective, we can take 1 over 0.085 plus 1 over 0.158. And so this one comes out to 11 ohms with our 2 significant figures, and this one with our 3 significant figures comes out to 6.33 ohms. Okay, so then to get the total, then we're just going to add the 3 together. So we have this one that was in series, we have this one for the first 2 that were parallel, and this one for the second two that were in parallel. So our effective is going to be equal to 31 plus 11 plus 6.33 ohms. We're going to be able to go out just to the ones place. So our effective then will come out to be 49. It'll be 49.33, but we can only go out to the ones place, so it's going to be 49 ohms is going to be R. Okay, so then we're asked to determine power. So we know that power is equal to I times V, or I squared R, but in either case, you need to figure out what I is. So P is IV, or P is I squared R. Okay, so let's go ahead and figure out what I is then. V is equal to IR. So V divided by R equals I. The V that we were given for this circuit in our drawing was 120 volts. The R that we determined was 49 ohms. So a volt over an ohm is an amp. And so this comes out to be, with two significant figures, 2.4 amps. Okay, so now that we know that, then we can go ahead and determine power. Okay, so power is I, which we just figured out is 2.4 amps, times V, which we were given as 120 volts. A volt amp is a watt, so 2.4 times 120, you're going to get 288 volts, amps, or watts. We can only have two significant figures, however, so it would be 290 watts, or 2.9 times 10 squared watts. We could have calculated it using I squared R. So if P is I squared R, so I was 2.4 amps, square that, times the resistance that we got was 49 ohms. And amp squared ohms is a watt, and if you do it that way, you should still get 2.9 times 10 squared watts. So that is that's problem number 10 for Module 15 practice problems.